Okay, good morning. Welcome to
FamilyMath number 462.
FamilyMath 462. Sorry, the camera's not quite right here. So actually, I mentioned yesterday we were going to do something, and you mentioned this old thing I had mentioned to you about from Dave Radcliffe about fractions adding up to other numbers. What made you think of that?
It was just something that we had looked at yesterday.
Oh, when did we look at it yesterday?
We saw it.
Oh, we just saw it yesterday?
Yeah.
Okay, cool. So, I'm not exactly sure when, a week or two ago, Dave Radcliffe posted a note saying any rational number, let's call it m over n, can be written as the sum of unit fractions. You know that as the sum symbol?
Mm-hmm.
Yeah.
Have you seen that before? Of 1 over
Something.
some 1 over, I already used n, so let's call it 1 over a, where a is an integer, and this is ends up being a finite sum. So it's pretty surprising. So in other words, like we can write 2 as 1 plus
A half.
a half.
Plus a fourth.
Well, what could we use next after a
A
half?
third.
Plus a third.
Plus a sixth.
All right, does that work?
Yeah, because a third plus a sixth is a half, and then it's a half plus 1 is 2.
Okay, so here's a great example. Now, if you used a fourth, it would get a little bit more complicated. But I don't actually know how complicated. But let's see what happens. So now we got to go. What we have to do, what we have left is a fourth to go. Right? We've got 1 plus a half plus a fourth, so we're at 1 3/4. What would you do next?
Plus an eighth. We could make this an infinite series, I
But
guess.
Right, but the point is it's got to be finite.
Yeah.
It's got to be finite. So yeah, if we go a half plus a fourth plus an eighth plus a 16th plus a 32nd, that'll be an infinite series that adds up to 2. But we want to make it a finite series. So how about I said we'll use a fifth. Okay?
So we have 4
So I've got to go a fourth more starting from here. So I've gone a fifth. So
We need
how
a
much
20th.
how much do I have left to go?
1/20th.
Plus a 20th. So here'd be another way to do it.
Cool.
So that shows you that there's not a unique way, even at least for some numbers, there's not even a unique way to do it.
Yeah.
Okay, but here's what is probably, I think, going to be a little bit of a surprise. Like, why do you think you can do this for a number like 100? Like 2, it's obvious. Well, obvious in a funny way. I mean, we were able to write down a couple of examples, but the fractions are starting to get pretty darn small. Even trying to add up to 2, I'm talking about using a fifth and a 20th. How in the world do you think I'm going to be able to get something that adds up to 100?
Using a lot of fractions.
Yeah. But the units get smaller and smaller every time.
Right, the units get smaller and
So it
smaller every
seems like
time. And I, by the way, I forgot to say you're only allowed to use each one once.
So
Yeah,
you can't
so-
do like 1 plus 1.
Yeah, I can't. Right, I can't do 1 plus 1 plus 1 plus 1. Sorry, I should have been a little more clear about that.
It seems like there would be like some maximum number that all the unit fractions add up to.
Right, yeah, that's the thing. Because like a half plus a fourth plus an eighth plus a 16th plus a 32nd only adds up to 1. So it's kind of surprising, even at the beginning, that you could do a number like 100 or 1,000 or 1,000,000. All right, so we got to, before we start looking at how to do this with numbers that are more complicated than 2, because even 3 gets really complicated. We got to find out why we can do it at all for big numbers. Okay?
Okay.